Right. Yeah. Topic for today is forward referenced data URIs. My name is Amia, and I'm a WebPerf engineer at Microsoft. This is a pretty early stage idea. We actually just a couple of weeks ago we published a blog post on some of the performance techniques that are used on Bing.com search engine results pages to load images, and I was exchanging some messages with Patrick Meenan, and he kind of brought up this idea. So I just ran with it a little bit. So I'd just love to get some early feedback on this concept of forward referenced data URIs. It's basically, the technique is a way to declaratively reference a data URI payload that will appear later on in the document. So right now, you have to declare the data URI exactly where it's used. But there might be some benefits to being able to reference data URIs that live in other places in this same document. And if this doesn't really make sense, I'll go through some examples that hopefully make that a little bit clearer. So one common use case is, imagine you have a page with highly dynamic content. So like there's not just a finite set of images, you just have a very large potential number of images that may or may not be displayed on that page. And the images are relatively small, so they're sort of thumbnails, so they're lightweight, and you have a desire to load them inline in the HTML using data URIs, just for efficiency of delivery. Like that just makes sense. Like users aren't going to be seeing those same images over and over again, most likely. So caching is not very beneficial. So you'd rather just inline those and send them down as part of the initial document. Just minimize the number of network requests that go out. And given that you have a very large catalog of images, it's not practical to pre-compute all the base64 encodings for every possible image. And it's not just a number of images, it's that each image could be rendered in multiple sizes and dimensions based on the viewport, based on the device pixel ratio. And there are different sort of places that surface images in different sizes. So just the combinations are just very large. So the pre-computing, it's not like, say, say a static blog engine or something like that, where you add a blog post and before you hit publish, it'll go in and convert whatever images you have in your latest blog post into base64 and just inline them on the page. This is much more dynamic. Just the number of images is too large for that to be practical. And the final piece is that the HTML, we assume that it's delivered using streaming, chunking, chunk transfer encoding, whatever you want to call it. So the page is following that architecture. So one clear example of a page that sort of fills this criteria is a search engine results page, but there might be other pages that also sort of fall into this category. Now, imagine just if we had a naive approach, and I'll show you an example page what this looks like, and just imagine a really simple page here. We have sort of an H1, 3 paragraphs, and some images that are interspersed between those paragraphs. So what does the source look like? It's pretty simple. We've got the H1, we've got the paragraph, and then we've got the image with the data URI, so base64 encoded versions of each of those 3 images here. So they're interspersed with each other. Now, if you're a web server, and you have sort of a dynamic service that's generating these image thumbnails, right? Remember, they're not sort of pre-computed. So on the server side, you'll generate a bit of HTML, then you realize, oh, I need to insert this image, right? And since you're going in linear order, you're outputting that markup and streaming it out to the user. You need to block, and then you're waiting for that base64 for that first image to be loaded, and then you proceed with the HTML, then you're blocked again, you proceed with the HTML again, you're blocked again, and then finally you output sort of the closing tag of the page. So you end up with this sort of inefficient waterfall approach on the server side if you followed a naive approach. So to work around that, what you might do is you sort of pipeline instead. So you might generate a page where since you probably have some kind of separate backend service that's generating those base64 URLs, you might fire off sort of a parallel background call to generate that and then keep moving on with your HTML. And you put the base64 markup at the bottom of your page. So now here we have the same page where it's been modified. So in the image tags, we put in like a 1x1 GIF. There are various sort of small, minimal versions of this available all across the internet. So this is sort of one of something that's like 41 bytes or so. So you put in these placeholders, and then you have code at the end of the page. So basically that, the service that's generating the markup is chunking it out, and you just inject it at the bottom of the page. So it's not blocking this markup. This markup can continue. And you have a little JavaScript function that basically takes an ID and a base64 encoding and updates the source for each of these. So it basically hoists these these base64 payloads into the appropriate image tag, and you end up with the page. So this is sort of what a current approach might look like. So you're no longer blocked on the base64 encoding being generated. And this is okay, but it adds, you need this inline JS on the page that you don't want to load this JS as part of an external bundle. You want this to run as quickly as possible. And you might have a bit of a race condition where the page might paint without those images being present. And then you have the JavaScript runs after that paint, and those get injected in. So the images don't load quite as fast as they would in the prior case, depending on timing. What if we could, in HTML, we could natively declare sort of a reference to a data URI payload that arrives later on in the document. And this is just sort of an example. The markup, don't treat the markup as final. I haven't given a whole lot of thought into this, but what if we had a way where we could generate those base64 payloads asynchronously on the server side, pass them in, and we had some sort of a forward reference to an ID, right? So like, let's say we have a data URI with an ID for the red square, the blue square, the green square. And over here, we had these forward references, and then the browser—
Can you bump up the fonts a bit? Because
sure,
folks are—
Sure. Is that better?
Okay. Slightly better. The screen is quite far away from a lot of us. Yeah.
Okay. Yeah. So over here, so we have the image tags, and in the source, we sort of have a new variant of a data URI attribute, where I'm calling it a forward reference. This is not final markup. I haven't given this a whole lot of thought, but sure. But it's basically referencing some kind of an ID, right? So this is referencing the red square. So it basically tells the browser that, hey, at some point in time in the future, in this document, there will be a data URI that has this ID to it. So when that appears, you can sort of natively hoist that into this image tag. And then the same thing follows. So these payloads are sort of generated asynchronously on the server. The HTML can continue to be generated without blocking and be streamed down to the user. And then once this stuff has arrived, the browser sort of natively hoists it into the right place. And this has a few benefits to this approach. So one is like I mentioned, the inline JS. It sort of eliminates the need for pages to implement this kind of JS, and it's pretty widespread across the internet. Techniques like this. Another advantage is just the repetitive nature of data URIs. So a lot of websites, they'll put in these 1x1 placeholder GIFs in their source attribute, because the source attribute cannot be empty. You need to put something in there, and but since you can't sort of share a reference to the same data URI at multiple points in the page, you end up duplicating that markup, right? So like that 41 byte example that I said, that might be present in hundreds of places on the same page, and the browser has to spend time decoding those individually. That decoding cost doesn't get shared. So what if you could reference a single instance of a data URI in multiple places on the page? That would also help reduce that overhead on markup. So I'm still thinking this through. This is still a pretty early stage idea, but I figured it'd be a good time to get feedback from folks in the audience, and if there are other concepts that exist. I started looking through the data URI spec. It's pretty old, like but it's pretty short, pretty concise. I think it hasn't really been updated since 1998. But if there are some similar concepts, similar ideas that have been discussed, love to hear more about that from folks in the audience.
I could note that data URI spec is in fetch, and fetch is being an URL spec. So What's Working Group is definitely updating those.
Yeah.